and it is necessary to keep track of the topology and inform neighboring devices if any changes occurred in the topology. In the link state routing protocol, a router transmits its IP address, MAC address and signature to its neighboring routers. This is a network example here. So in the network we have A, B, E, D, E are the routers. Dear students, welcome to Computer Science classes. I am Ravi Kumar KR, lecturer in Computer Science, Vidhyaashram First Grade College, Temple of Excellence, MYSURU. Students, let us start our discussion with the concept data link layer. So, in this session, we are going to discuss about routing algorithms, distance vector routing algorithms, and link state routing. These are the topics to be covered in this session. Let us start with, first one is distance vector routing. Now all of you know what is a router, and it is a network device. Each and every router is going to broadcast its routing table information to all the routers on the devices in a network. See, that is a concept we have covered in our previous session. So in this session, let me talk about what is distance vector routing. See, this is another method of routing algorithm, that is distance vector routing. So distance vector routing protocol. So it is a protocol also called as Bellman-Ford algorithm. So another name for this is Bellman-Ford algorithm, and it is used to calculate a path. So it is going to decide the best path between the host and destination to transfer the data in a network. So the distance vector protocol, it calculates the distance and direction of the vector of the next hop from the information obtained by the neighboring router. So as you have seen in the diagram, if you look at this diagram here, see, this is an example for distance vector routing. See, these are A, B, C, D are different types of network device or a router in a computer network. So here this protocol calculates the distance and direction of the vector of the next hop from the information obtained by the neighboring router. So with the help of information from the neighboring router, which they are directly connected, it gets the information and decides the best path between the host and destination. And it is necessary to keep track of the topology and information and inform neighboring devices if any changes occurred in the topology. So another function of this router is nothing but is going to broadcast its routing table with different routers in a network. So accordingly, it is better to, or it is a responsibility to keep track of the topology, in the sense the way we are going to connect the network devices or peripherals in a network, or any changes in the computer network that has to be updated in the routing table of each and every router in a network. So accordingly, see, this is distance vector routing. It is also called as Bellman-Ford algorithm. So it is going to calculate from the distance between the host and destination based on the hop or with the next router. Now this is Bellman-Ford algorithm. So this is the formula. The dx of y equal dx of y means the distance between the distance from x to y. The distance from x to y is nothing but from host to destination. It is based on the cost of the link or the cost of the node of its neighboring. So the distance to each node from the initial node is calculated with the help of this formula. So this is Bellman-Ford formula or algorithm to calculate the distance between the host and destination in a network. So this is Bellman-Ford algorithm. Now let us take an example for distance vector routing. In this routing example, so this is a network. Here we have number of routers. So namely A, B, E, D and C. These are the routers in a network. Now let us find out the distance vector table for B. We have to find out the vector table for the node B. Here how do we calculate this? See, first of all, I want to find out the destination from B to A. So if B to A, there is only one direct connectivity, the hop count is 1. So here from B to A, destination is A, next hop is A, they have only one device connected to it, and the hop count is 1. So this is 1 here. Next one is we have to calculate for this C. We have to calculate for C. So destination is C. In the destination C, so as it is directly, C is directly connected from the node B to C, so the hop count is 3. So this is next hop is 3, hop count is 3. Now if you look into the next one is for D. For destination is D. So if destination is D, we can take the route from B, C, D. So this is one of the path from B, C, D. In that case, so next hop is C and count is this 3 plus 7, that is 7. 3 plus 4 is 7. Next one is the destination is E. If the destination is E, if the destination is E, so B is directly connected to this E, node E directly, so without any intermediate network devices. So from B to E, count is 9, so this is count is 9. So if you look at this is a distance vector table for B. So by looking at this, so from distance from B to A, so we need to have a routing table for B. See, this is distance vector table, and each and every router will be having its own routing table. So in the routing table, we are going to have the destination A. If you look at the table here, from B to A, if you look at the count, 1 is the minimum, or this is the minimum value of the count in a network. So we have to consider this. So from B to A, the best path is the direct connectivity, or the router A has direct connected to router B. In that way, we have to consider the best path, or the path which will be having the least hop count. So this is your hop count. So based on that, so this is for destination A. And similarly, we need to have a one more distance vector table for E, and again for D, C, A. So by in each and every network, this distance vector table has to be calculated for each and every router in a network. So accordingly, based on this concept here, so we have to consider this. Based on that, we can have a routing table for the router B. So this would be the routing table for B. So these are the values, these two are the values we got it from the distance vector table for B, similarly for different network devices. So this is how to find out the distance vector routing, or the best path which will be having the least hop count. So this is distance vector routing. In the next slide, we will see another type of routing that is called link state routing. So what is link state routing here? So here, link state routing is a technique in which each router shares the knowledge of its neighborhood with every other router in the network. So the meaning here is each router shares the knowledge of its neighborhood, only neighborhood, with every other router in the internet network. So, but if you look at the previous example here, so in the distance vector routing, so this router is going to share its table with each and every devices router in a network. But in the link state routing, see the information, the router table information is shared only for its neighborhood or the neighboring devices or the network devices. In the link state routing protocol, a router transmits its IP address, MAC address and signature to its neighboring routers. So if you look at the example here, in this example, suppose the router table of B is going to transfer its, or is going to share its information with A. For example, this is the neighboring router. So it is not going to broadcast to all the network devices in the network, only to its neighborhood or neighboring nodes. In this example, probably it's going to share information with A, C and E. And what type of information is shared from the router? So informations like the IP address, MAC address and signature to its neighboring routers. Now using the information, that's the IP address and other details, the neighboring routers creates a record by combining the IP address and the MAC address. It's going to have its own record by having these details. This information helps the router to transmit the data packet through the optimal path. And it also tells the router about the various possible paths. So what is the advantage of this? So it's going to create a record. So the record which contains the information like IP address and MAC address and other details of a network. So it will be created in a router, and the same information, this record or information, is transmitted to the router so that any router, so it can select the optimal path or the best path among number of paths available in the network. And all the nodes will be getting the link state information from all other nodes. If you look at the example here, so suppose this is the one is going to share its information from neighboring nodes, it goes to other devices in a network. So this is link state routing. Now let us see an example for this. So here this is a network example here. So in the network we have A, B, E, D, E are the routers. And now look at this here. So this is a table for node, and this is the node B and node C, cost is 1 and 5. And if you look at this table, it says node A and B, the cost is 5 and 3. This is a link state table for router C here. Now if you look at the router here, for example router C, what is the link state information here? In the link state information, node is A. See, from C, node is A, destination node is A, and here the count is 5 or the cost is 5. And again this is connected to B, for example. So B, what is the node is B, what is the count is 3. So this is the cost of the path from B to C is 3. So similarly, it is going to have a number of node information for each and every router. For example C, and this is for example B, router A here. So from A and A to B, cost is 1, and A to C, cost is 5. So if you look at this example here, and each and every router is going to maintain link state table. This is called a link state table for every router, and this link state table is shared with the neighboring devices or neighboring router. It is not going to share the information across the network, and it shares information only to the neighboring nodes. For example, like from B to E, B to C and B to A. So this is a link state routing, and this is a link state table maintained for each and every router in a network. So students, so far in this session we have learned that routing algorithms, that's a distance vector routing algorithm as well as link state routing algorithm. Now let us continue our discussion in my next session. Thank you very much.